Good day, everyone. Our research is entitled Adsorptive Removal of Lead-2 Ions from Aqueous Solutions using Eggshell-Based Chitosan coated to powdered activated carbon.
Now for the background of the study. One of the environmental problems in the Philippines is the presence of the different heavy metals in wastewater. And one of those metals is lead. We found out that lead can cause different diseases and disorders. Due to this reason, we thought of a solution to prevent lead contamination in water. We chose PAC, or powdered activated carbon, and chitosan gel in this specific research. Activated carbon is commonly used in filtration because of its batch and column systems, while chitosan has a high affinity in adsorption because of its metal binding functional groups. Previous studies were made in the adsorption of heavy metals using these materials independently. We thought of combining these two to produce a better product.
For our scopes and limitations, powdered AC, sodium hydroxide, hydrochloric acid, and analytical equipments were obtained from Manila Science High School. Filter paper was purchased from Chrisman Enterprises, lead from MANILA. In the course of the experiment, some equipments are owned by DOST's SCD and by MANILA. The study has undergone batch equilibrium tests such as flame atomic absorption spectrometry performed in MANILA. The study is limited to the comparison of other known physical-chemical processes of filtration. It will not hold other type of tests, processes, and analysis regarding the novel bioabsorbent. It shall be limited to the availability of time rendered in the said processes. The study is closed to other types of substrates to related research. Problem: will the bioabsorbent be capable of removing lead ions from factory wastewater?
Significant for a vast amount of purposes. First of all, it's cost-effective water treatment. Compared to the filtration processes used by factories, our product is less expensive and more effective. Environmental health production, as what I said earlier, lead can cause different diseases. Our product reduces the risk of contamination and avoid environmental health problems such as water and land pollution. Lastly, it contributes to the existing body of knowledge.
Let us now move on to the methodology. The materials used were eggshells, powdered activated carbon, sodium hydroxide, hydrochloric acid, lead solution, and distilled water. To form chitosan gel, chitosan will be extracted from eggshells. The eggshells will first undergo demineralization by soaking the eggshells in diluted hydrochloric acid. The demineralized shells will be deproteinized by soaking them in sodium hydroxide solution. This will form chitin, which will be crushed and then deacylated with sodium hydroxide solution. The chitosan obtained will be transformed into chitosan gel by diluting it in hydrochloric acid. And then, the chitosan gel will be used in coating the substrate, powdered activated carbon.
For the batch adsorption studies, 6 setups were prepared in 6 corresponding Erlenmeyer flasks. 2.5 grams of chitosan-coated activated carbon was constant in all setups. The 30 ml metal solutions were varied. 3 setups contained an initial concentration of 200 ppm, while the other 3 setups contained an initial concentration of 25 ppm. All setups were agitated at a constant speed of 50 rpm, with varying contact times, 30, 150, and 240 minutes. All setups were filtered and tested using flame atomic absorption spectrometry, or also known as flame AAS.
Go!
To determine the kinetic absorption mechanism of the chitosan-coated activated carbon, 2 kinetic models, the pseudo first order, or also known as the Lagrangian kinetic model, and the pseudo second order equation, were both examined and applied to the gathered experimental data. As you can see in the table below, We can use these parameters in order to measure the kinetic mechanism involved in the experimental data by obtaining the log QE, the K, and the R squared. For the disposal or desorption method, we use the leaching process or the process of giving off of the substrate of the heavy metal ions. For this, we use edetic acid because it is less harmful and it easily gives off lead ions such as we use in this methodology. For the results and discussion, we first examined the effect of initial concentration and contact time to the experimental data. As we can see in the first figure, the adsorbance instantaneously grows by the time it reaches 2.5 hours. The first 0.5 to 2.5 hours easily and enormously grow among the adsorption levels of 2.5 to 4 hours because of the repulsive forces inside these binding sites that repels the remaining lead ions in the solution, having a difficulty for mass transfer zone. This is also attributed, and as we can see in table 2 or the adsorption data of lead-2 ions using flame AAS, we can see the impressive results of our experimental data. And as for the kinetic studies, we use this table or for the corresponding values of the pseudo first order and pseudo second order equations. We use these to compute the logarithm of the equilibrium time quantity and the time quantity of 30, 150, and 240 minutes for these two concentrations. We determine the slope and the intercept by using the formulas that said earlier in the methodology. We also obtained the 1 over qt and 1 over t for the pseudo second order equation. As you can see, the low values of K1 and the low values of K2 with having negative over negative, the values that was set earlier can be used to compute the parametrics for the pseudo first order and the pseudo second order equations such as K1, K2, and R squared, but also logarithm of the equilibrium time for the corresponding data. As you can see, all values of K constants are negative, and this is because of the fast equilibrium time of 4 hours and the fast adsorption rate of the kinetic data. As we can see, the R squared values of the pseudo second order equations was higher than the R squared values of the pseudo first order equation. Now, the higher values of the pseudo second order equation generally implies that the binding mechanism of the adsorbent to the adsorbate is chemisorption. So what is chemisorption? Chemisorption is the formation of covalent bonds for the easier binding sites of the biosorbent to the biosorbate. Formation of covalent electrons, formation of covalent bonds of these heavy metal ions could easily be implied as the general adsorption mechanism of the experimental data. For the conclusion, the biosorbent chitosan-coated activated carbon has demonstrated a high adsorption affinity of lead-2 ions from the aqueous solutions. The rate of lead-2 ions adsorbed increases as the initial concentration increases. This is because, again, of the easier mass transfer zone and the contact time of lead-2 adsorption to the adsorbent was also investigated to determine the equilibrium concentration of the solute. And we inferred that the equilibrium concentration was from 4 hours to up to a point where the adsorption will stop. Moreover, the pseudo second order kinetics was used to describe the controlling mechanism used to experimental data. This indicated that the adsorption was chemisorption, and that covalent bonds was formed by the adsorbent and the heavy metal to initiate adsorption. So, what is this adsorption? Adsorption or chemisorption could be implied as to generating a powerful, a less. Moreover, the behavior of chitosan-coated activated carbon was investigated. So, by this experimental data, the chitosan-coated activated carbon biosorbent could generally fit as a large-scale water filter that has active permeable barriers for mass transfer zone and mass transfer exchange. This could be used to filter factory wastewater to be used again throughout the factory, and this could serve as a large-scale water filter for the community to avoid lead contamination in groundwater systems. That's all. Thank you.